Hello. Today we're going to discuss conjoint analysis. Conjoint analysis is one of the most widely used research methods for understanding consumer preferences. Instead of asking people what they like, conjoint analysis observes the choices they make when forced to make trade-offs. In this example, we'll use a fast food meal scenario to show exactly how conjoint analysis works and how researchers turn choices into business recommendations. The objective of this study is to understand what drives consumer choice. We want to identify which attributes influence decisions, quantify the trade-offs consumers make, and determine which combinations are most likely to succeed in the market. Ultimately, the goal is to support better business decisions using data rather than assumptions. In a choice-based conjoint study, respondents are shown multiple options and asked to choose the one they would purchase. Each option contains a different combination of attributes. By observing these choices repeatedly, we can estimate how much each attribute influences decision-making. The key idea is that people reveal their preferences through choices rather than directly stating them. In this example, every meal is built from 4 attributes. Price can be $5.99, $7.99, or $9.99. The main item can be a burger, salad, or chicken sandwich. The side can be fries, hash browns, or fruit. And the drink can be soda, water, or juice. Each meal option shown to respondents is created by combining one level from each attribute. If we simply ask consumers what they want, many would say they want the best food, the lowest price, and the healthiest ingredients. But real-world decisions require trade-offs. A consumer may prefer a chicken sandwich to a salad, but perhaps not if the price is much higher. Conjoint analysis measures preferences by forcing realistic choices rather than collecting opinions in isolation. This is an example of a choice task that a respondent might see. Option A is a chicken sandwich with fries and soda for $5.99. Option B is a burger with hash browns and water for $7.99. Option C is a salad with fruit and juice for $9.99. The respondent simply selects the one meal they would choose. They are not ranking attributes and they are not explaining their reasoning. They are only making a choice. A single choice task is not enough to estimate preferences. Each respondent completes multiple tasks. In every task, the combinations change. A chicken sandwich that appears with fries in one task may appear with fruit in another. Prices also change across tasks. By repeatedly observing choices across many different combinations, we generate the data needed to estimate preferences. Once all responses have been collected, the model analyzes every choice made across every task. It looks for patterns. For example, if respondents repeatedly choose chicken sandwich options over burger options, the model estimates that chicken sandwiches provide more value. If respondents consistently avoid higher prices, the model estimates that price has a negative impact on choice. No attribute is rated directly. All preferences are inferred from observed behavior. Because each respondent makes many choices across many combinations, the model can statistically estimate how much each feature influences decisions, turning thousands of individual choices into numerical preference scores. After estimating preferences, we can calculate attribute importance. This chart shows how much influence each attribute has on decision-making. In this example, price is the strongest driver of choice. The main item is the second most important factor. Side and drink influence decisions as well, but to a lesser extent. This helps us understand what matters most when consumers make trade-offs. Keep in mind that attribute importance and level results answer different questions. Importance tells us which category matters most overall, such as price, while level results tell us which specific option wins within a category, such as chicken sandwich over a salad. We can also examine performance within each attribute. Among main items, chicken sandwich performs best. Burgers rank second. Fries are preferred over hash browns and fruit, and soda is slightly preferred over water and juice. These findings help identify which specific features are driving choice. One of the most powerful features of conjoint analysis is market simulation. Once preferences have been estimated, we can test the hypothetical products before they are launched. In this example, the chicken sandwich, fries, soda, and $5.99 price combination performs best, capturing about 48% of simulated choices. The burger option performs moderately well, with about 33%. The salad option performs worst at about 19%. This allows companies to evaluate different concepts before investing in development or launch. Based on the results, we can make clear recommendations. Chicken sandwich should be prioritized as the core menu item. Pricing should remain within $5.99 to $7.99 range. Fries should be the default side, and lower performing combinations should receive less emphasis. This demonstrates how conjoint analysis turns consumer choices into actionable business decisions. Like any research method, conjoint analysis has limitations. This example reflects a simplified decision environment. It does not include branding, advertising, or other marketplace influences. For that reason, the strongest concepts identified through conjoint analysis should be validated through real-world testing. However, conjoint remains one of the most effective tools for understanding consumer trade-offs and predicting choice behavior. Thank you for watching.